Hello everyone, in this video we're going to explore topic 9.1 defining and differentiating parametric equations. Now first we're going to graph parametric equations. Definition of a plane curve: if f and g are continuous functions of t on the interval I, then the equation s equals f of t and y equals g of t called parametric equations, and t is called the parameter. The set of the points s and y obtained as t varies over the interval I is called the graph of the parametric equations. Taken together, the parametric equations and the graph called the plane curve denoted by C. When sketching a curve by hand represented by parametric equations, you use increasing values of t. Thus, the curve will be traced over a specific direction. This is called the orientation of the curve. You use the arrows to show the orientation. Alright, so let's take a look at the first example. Sketch the curve described by the parametric equation s equals t squared minus 4 and y equals t over 2 for t from -2 to 3. Alright, now if t equals -2, you substitute -2 for t into the equation right here, right? So s equals 0 and substitute t into this equation right here. So y equals -1, right? Similarly, t equals -1, t equals 3, it's going to be 5 right here, and it's going to be 5 over 2, right? Alright, now let's plot these points on the xy coordinate right here. So x equals 0, y equals -1, it's going to be right here, right? This one is the starting point. X equals -3, y equals -1/2, so it could be right here. X equals -4, y equals 0, it could be right here. X equals -3, y equals 1/2, right here. X equals 0, y equals 1, it could be right here. And x equals 5, y equals 2.5, so it could be right here, right? So you just connect this point. Alright, now you just put the arrow starting from here. Now we can use the calculator to check our work, right? So you're gonna bring up the calculator at graphs right here. You need to go to menu, graph entries. You need to change this one to parametric, which is number 4 right here. Alright, the first equation is x right here, t squared minus 4, right? So you just input t squared minus 4 and y equals t over 2, right? And for the domain of the t value, it should be -2 to 3. So you just override this one, -2 and 3, right? And the t step right here, you just leave it. And you hit enter, it's going to be right here. Now if you want to see how the graphs moving, just press menu, trace, and then plus right here. And press number 2 right here, right? And you just press the stop animation right here. And just enjoy how it looks like. And then it's gonna stop right here, right? It stop from here and stop right here, right? Now let's move on to example number 2. We do exactly the same thing as example number 1, right? Now t equals 1, substitute over here, you have sine pi over 2, it's gonna be 1, it's 1, 1. T equals 2, substitute over here, it's gonna be sine pi, it's gonna be 0. This guy 2, right? T equals 3, sine of 3 pi over 2 is going to be -1. This guy 3. T equals 4, substitute over here, it could be sine of 2 pi is going to be 0. And this guy is 4. T equals 5, sine of 5 pi over 2. it's gonna be 1. And this guy should be 5. And t equals 6. Substitute over here, it could be 3 pi. It's gonna be 0 and this guy 6. Alright, now you're gonna plot this point on the x and y coordinate, right? X equals 1, y equals 1, it's gonna be right here. X equals 0, y equals 2, it's gonna be right here. X equals negative 1, y equals 3, right here. X equals 0, y equals 4, it's gonna be right here. X equals 1, y equals 5, it's gonna be right here. X equals 0, y equals 6, it's gonna be right here. Alright, so if you connect this point, it could be something like this. Now you just place the arrow right here. Alright. Now observe that if you let x equal, t equals 0, and then x should be 0, right? So we have the left endpoints right here, 0. Y should be 0, so it could be the origin right here. Right? So you just connect this guy. And you see that it's gonna go this way, right? Now you're gonna use the calculator to check your work, right? So you're gonna hit tab x2, y2, right? You need to hit upper arrow right here. Alright, so you're gonna put sine of pi t over 2. So you're gonna press check right here, sine of pi t over 2, right? So pi should be right here, and t divided by 2. Now y should be t only. Now the value of t is from 0 to 6, so you need to override this one. 0 and 6. You hit enter, it's gonna be right here, exactly, right? Now if you want to see how the graph moving, you just press menu, go to trace, number 4 and number 2. Press enter. Now let's move on to the next one, eliminating parameters. Example number 3. Sketch the curve described by the parametric equations. X equals this one and y equals this one, where t is greater than negative 1, by eliminating the parameter and adjusting the domain of the resulting rectangle's equation. Alright, so we have s equals 1 over square root of t plus 1, right? From this equation, we need to solve for t, right? Now, square root of t plus 1 is 1 over s, right? Square both sides is going to be t plus 1 equals 1 over s squared, right? Then subtract 1 both sides, so t equals 1 over s squared minus 1, right? Now substitute this one for t into the function right here, right? So we have y equals 1 over s squared minus 1 over 1 over s squared minus 1 plus 1, right? So this guy turns out to be 1 right here can be written as s squared over s squared, right? So I have 1 minus s squared, right? Over negative 1 right here and 1 right here cancel out. I have 1 over s squared left, right? It's 1 over s squared right here. Now since I have s squared left right here, I need to bring it to the bottom, so it can be s squared right here, right? So this guy right here and this guy right here cancel out, right? So the answer is 1 minus s squared. This one is the y value, right? So y equals 1 minus s squared. Now we need to adjust the domain of the resulting rectangle equation, which means we have t greater than negative 1. Does that mean this guy always greater than 0, right? Then s right here must be greater than 0, right? So this one is the quadratic functions, right? So x equals 0, y equals 1. We have the first point right here. X equals 1, y equals 0. Right? It could be right here. X equals 2, y equals -3. So it could be right here. Right? So if you connect this one, it could be something like this. Now, observe that x always greater than 0. Actually, you have another branch on the left hand side right here, but we don't need that one, right? We only need the one on the right hand side because x always positive. Alright, so you just place the arrow. Now you may use the calculator to check your work. Now let's move on to definition of smooth curves. Let's see, denote a plane curve represented by parametric equations s equals f of t and y equals g of t for t between a and b inclusive. Suppose each function s of t and y of t is continuous on the closed interval a and b, and differentiable on the open interval a and b. If both ds over dt and dy over dt are both continuous and never simultaneously 0 on the open interval a and b, then C is called a smooth curve on the closed interval a and b. Alright, let's take a look at this one. Differentiating parametric equations. Theorem 1. Parametric form of the derivative. If a smooth curve C is given by the equations s equals f of t and y equals g of t, then the slope of the curve C at the point s and y is dy over ds. Now I'm going to divide the top and bottom by dt, so I get this one right here. Right? Observe that ds over dt right here must be different from 0, so that this guy define. Right? Now, horizontal and vertical tangent lines. Remember, we have the Christmas tree trick. If the lines go in this way, the slope is positive. If the lines go in this way, slope is negative. If the line is horizontal, the slope is 0. If the line is vertical, the slope is undefined. Right? Now, we're going to talk about the horizontal tangent line. At a number t where dy over dt equals 0, but ds over dt is not equal to 0, right? Look at this one right here. If this guy equals 0 and this guy not equal to 0, then dy over ds must be equal to 0. But dy over ds is the slope, right? So then a smooth curve C has a horizontal tangent line, right? Because dy over ds becomes 0, it could be right here. It could be horizontal line, right? Now add a number t where ds over dt equals 0, right? Which is the bottom right here equals 0, right? So does that mean the whole thing right here must be undefined, right? Then dy over ds is undefined. In other words, the slope is undefined, which is the vertical right here, right? So we have the vertical tangent line, right? Now let's take a look at example number 4. Consider the plane curve defined by the parametric equation s of t equals 3t squared and y of t equals 2t. Find an equation of the tangent line to the curve when t equals 1. So you need to use the point slope form formula, right? Y minus y1 equals m times s minus s1, right? Now you need to find the slope first, right? The slope actually dy over ds, right? So it's going to be dy over dt divided by ds over dt, right? Dy over dt, which means you need to take derivative of the function y right here with respect to t. So does that mean it's going to be 2, right? And ds over dt, you're going to take derivative of this one with respect to t, right? So it could be 6t, right? Then you substitute 1 for t right here, right? So then dy over ds when t equals 1 becomes 2 over 6 and it's going to be 1/3, right? You need to find the value of y1 and x1, which is the coordinate point, right? So you just substitute 1 for t into the function right here to solve for x and y, right? So t equals 1, you have s equals 3, y equals 2, right? Then the equation is y minus y1, which means 2 equals 1/3 times s minus 3. This one is the equation of the tangent line, right? Now, question B. Find all the points on the curve at which the tangent line is vertical, right? So you know that the tangent line is vertical when ds over dt equals 0, right? So you have ds over dt equals 0. Then you have set t, right? Because you take the derivative of the function s of t with respect to t, right? So it could be 0, and then t equals 0, right? Now, you need to find the order pairs, right? So substitute 0 for t back to the equation right here, right? So you have s of 0 is 0 and y of 0 is 0, right? So the vertical tangent line to this curve is at 0, 0, right? Now let's move on to example number 5. A curve that crosses itself. A plane curve represented by the parametric equations s of t equal t cubed minus 4t and y of t equal t squared crosses itself at the point 0, 4 as shown in the graph to the right, and thus has two tangent lines. Find the equation for these two lines, right? So again, in order to find the equation of the tangent line, you need to find the slope, right? So the slope is going to be dy over ds equals dy over dt divided by ds over dt, right? Now, the top one, take derivative of the function y with respect to t, right? So it could be 2t. Now the bottom, take the derivative of the function s with respect to t, right? So it could be 3t squared minus 4, right? Now, given the point 0, 4, which means s equals 0, y equals 4, right? So I substitute 0 for s into this equation right here to solve for t, right? So I have t cubed minus 4t equals 0, right? So this guy turns out to be t times t squared minus 4 equals 0, right? And then t times t minus 2 times t plus 2 equals 0, right? Then you have t equals 0 and t equals plus and minus 2, right? You substitute 4 for y into the second equation right here. So you have t squared equals 4. Then t equals plus and minus 2, right? So you have three values. Now you need to check each value. For t equals 0, then you have s of 0 equals, substitute over here, you have 0, right? And y of 0 is 0, right? And you look at this one right here, you have the order pair 0, 0. 0, 0 right here is not the intersection, right? T equals 2. Then you have s of 2 equals 8 minus 8. It's going to be 0, right? And y of 2 equals 4, right? So you have the order pair 0, 4. This is the intersection right here. So this is works, right? Now t equals -2. You have s of -2 equals -8 plus 8, right? Equals 0. And y of -2 is still 4, right? So the order pair right here is still 0, 4, right? So you're gonna drop this one out, right? You don't need this one, right? Because this one is not the intersection, right? You have two values, t equals 2 and t equals -2 right here. And since you have the intersection right here, right? So go back over here. You need to find the slope of the tangent line, right? So you have dy over ds evaluated at t equals 2. Substitute 2 for t into this equation right here, right? So you have 4 over 2 squared equal 4 times 3, it could be 12 minus 4, it could be 8, so it could be 1/2, right? And second one, dy over dt evaluated at t equals -2, right? So 2 times -2 equals -4. This one should be 8, and the answer is -1/2, right? So you have two tangent lines. The first one has the slope right here. The second one has the slope right here, right? And you see the order pair is right here and right here, right? So the first equation, y minus y1, which means -4, equals the slope, which means 1/2, right? Times s minus s1. S1 equals 0 right here, so you don't need to write it, so just write s, right? The second equation, y minus 4 equals -1/2 s. That's it, right? Now let's move on to example number 6. A projectile is fired at an angle theta from 0 to pi over 2 to the horizontal with an initial speed v0 meters per second. Assuming no air resistance, the position of the projectile after t seconds is given by the parametric equation. S of t equals v0 cosine theta times t. Y of t equals -1/2 g t squared plus v0 sine theta t for t greater than or equal to 0, where g is the acceleration due to gravity. Find the slope of the tangent line to the motion of the projectile as a function of t. Alright, so we have dy over ds is the slope of the tangent line, right? So this guy turns out to be dy over dt divided by ds over dt, right? Now, the first one right here, you need to take the derivative of the function y with respect to t, right? So this guy turns out to be -gt, right? Plus v0 sine theta, right? Now, take the derivative of this function with respect to t. It's going to be v0 cosine theta, right? Now let's move on to question B. At what time is the projectile at its maximum height? Now go ahead, sketch the graph. It's going to be something like this, right? The maximum height, which means the highest point right here, right? So right at the highest point, you have the tangent line, right? It's going to be right here. And of course, the tangent line should be horizontal, right? When the tangent line is horizontal, the slope is 0 right here. Look, this one right here, right? So you have dy over ds equals 0, right? It's the same thing as this guy right here equals 0, right? And this one is the fraction. You only need the numerator equals 0, right? So you have -gt plus v0 sine theta equals 0, right? Then you just solve for t, right? So -gt equals -v0 sine theta, right? Divide both sides by -g, so t equals v0 sine theta over g, right? And this one is the final answer, right? And it's good time to solve. Thank you for watching. I hope you enjoyed the video. Remember that if you failing to prepare, you're preparing to fail.
We rise like tall buildings. the chemicals that take us higher. The night's young, it has just begun, as she puts her hand in mine.